how test. And it basically does all this stuff, and it compares the coefficients and the variance of the coefficients to see if they change when we delete the category. We can do all this by hand. It's fun. We have nothing better to do. Or Stata can do it for us. So type that. We can run this mlogit test. You add in that option IIA, and it does all of it for you in however long that took you to do. And it does, actually there's 3 different tests. The first one is the Hausman-McFadden test, and it gives us a, let's see, where is it? Hausman-McFadden test, yeah, it tests deleting each category, and as you can see, the chi-square value is relatively small. The p-value is relatively large, meaning that we can't reject the null hypothesis, and the null hypothesis is that the independence of irrelevant alternatives holds. So the null hypothesis is that IIA, we're satisfying IIA. We can't reject it. We didn't really talk about this test, but we did talk about the small how test. And again, we've got negative values here, large p-values of 1. The null hypothesis is again that independence of irrelevant alternatives holds. This appears to tell us that, yeah, you guys are good, you can't reject it. It doesn't make sense. You would think that fishing, that these things are substitutes, that at least fishing off the pier and the beach are probably substitutes, and then fishing off your own boat and hiring a charter are probably substitutes. Here they're finding no problem with it. Again, we know they're subject to lots of problems. Okay, so we've already done enough mlogit stuff. Let's do conditional logit. So that's the data. Again, one row is one incidence of someone fishing. We need to create the data in what's called long form, where instead of having one person facing a price, facing the price of beach, pier, private, and charter, we're going to have that one person, and let's just say that they have an ID, and they're person 1. They're going to have 4 observations, where one is going to be charter, beach, pier, and private. We did the reshape command, right? Yeah. What's that?
It's been a while.
It's been a while, yeah. So we're going to reshape this, and remember we need that stub, and these are already set up for us to de-stub, because these already have a price on. So price of beach, price of pier, price of private, price of charter. We're going to say cut off that P and put this in a format so that so this is going to be type, and this will be, we'll create a new variable called price, and then essentially we're going to cut off these and align this beach with that beach, so we'll get the appropriate prices in each of these. So again, instead of having 1 observation per ID, we're going to have 4 observations per ID, and the data set should go from smaller to larger. That's more observations. All right, we need to generate an ID because we don't really have one. That's easy enough. We can just generate 1 through whatever we need. And let's see. Now, normally, let's see. I'm not going to do this, but normally we could have done this. And our data set would construct new variables. Remember, D is going to be the is our dummy, and it'll tell us which one they chose. P is going to be the price taken from these stubs, and Q is going to be the catch rate taken, and they had similar stubs, right? It was QP, Q Beach, Q Pier, Q Private, and Q Charter. Those were the catch rates. We're going to construct this new variable called fish mode, and it's a string variable, so that's why we put string there as opposed to a number. The reason why we can do this, but what we're telling Stata is to find everything with a D, which were those dummies, and chop off everything after the D. Yeah, there's D Beach, D, so these are those dummies. Find everything with a P, and those were the prices, which we have listed here. Price Beach, price Pier, price Private, price Charter. And find everything with the Q and chop off everything after the Q and construct this thing named fish mode. The reason we can't do this is because if we tell Stata to chop everything off with a P, what's it going to do?
The pure, the private.
It's going to construct all those, but what else starts with P?
Price.
Price. It's going to construct a new mode called what? Rice. Rice, exactly. There is no rice. This price reflects the price that they paid for the mode. So notice that this price, they chose Charter, and this is that's the price they paid for the Charter. It's almost embarrassing to say, but that was like straining my back to reach up there. It's like, wow, that hurts. Maybe I should take up yoga or something. So we can't do that. So basically, we're going to tell it, yeah, to do that, but only do it for the variables that we want you to do it for. And hence, we tell it to do it for, I don't have to stretch now, do it for Beach, Pier, Private, and don't do it for Rice. So if we had left it out like we did before, if we had done it this way, we get that category called Rice. We'd probably drop that category, but it might have screwed things up. Actually, we should do it just to see how badly it screws things up. But here we just get around that. So boom. Remember, we started out with (1,182) observations in wide form. We go to 4,728 in long form. And it tells us that we did that there. We had 17 variables, now we only have 9. And it tells us what we did. We took the D off of all these and created D, which is your decision. We took the P off of all these, and that creates our price. We took the Q off of all these, and that created our quantity. We didn't, yes, we didn't take the P off of price and create something called Rice. All right. Now we have to construct, we can look at the data again. Notice the ID for ID 1, we got 4 observations. Again, number of observations for each ID, as we the same number of observations for each ID as we have alternatives. We have 4 alternatives, hence we have 4 observations for each ID. And you can see that the alternative specific variables differ. We should delete that out of the thing. First I strained my back, then I tripped over.
Saving up the blooper reel.
Yeah, the blooper reel. We have our alternative specific variables that differ across each alternative. We have our case specific variables that are the same for each ID. So income, again, doesn't change across those. So it looks like things are nice, are set up nice, case appropriate. D is, D's a 0-1 dummy, and it indicates which decision, which choice we made. So is D up there? Yeah. So charter, as you can see for the first one, charter had, for D, charter has a 1. And I guess for the second one, charter has a 1 also. All right. Let's generate the dummies. We're going to tab, remember fish mode is the variable that we constructed. And it's actually a string variable, so if we do no lab, it's still going to be the same. And it's a string variable because when it's a string in 2, we told Stata it was a string. So this is where that string option comes in. We need some dummies for each category. So we're just going to tab gen. Tab fish mode, generate mode 2. And then we're going to rename those so we don't have to memorize that fish mode 2.1 was beach, and 2.2 is charter, and 2.3 is pier, and 2.4 is private. So now we have those dummies. There. Mostly want to see this. Yes, everything looks right. So this is how we want the data set up. We've got the dummies we just created using the tab gen, and then we've got the fish mode that was generated using the reshape command. All right, we can do a conditional logit. We got our dummy, our binary, our price, our quantity. Remember that conditional logit can only handle alternative specific variables. So if we run this, we run it correctly, which is what this is, it only handles the alternative specific variables. You can throw in some dummies in there to get fixed effects. And the coefficients change a bit. But we know that we have alternative as well as case-specific variables. We have income. So we can't really use conditional logit. We need to use what's called the McFadden choice model. And that is this command here. So what that means is that this is AS, alternative specific conditional logit. This is our mixed model. And it handles our alternative specific variables, price and catch rate, as well as our case specific variables, and this is indicated by the case variable here. In the parentheses is our case specific variable income. And again, this is our model of choice. And we talked about the interpretation here. The interpretation of the alternative specific variables is that, again, price is negative. As the price of one alternative goes up, the probability of choosing that goes down. It's negative and significant, which is nice. And as the catch rate of one alternative goes up, the probability of that alternative goes up, and the probability of the other alternatives goes down. For our case-specific variable income, that's going to be indicated in each of these categories. So it's negative but not significant for charter, it's negative and significant for peer, and it's positive and marginally significant for private. Let's see, can we test this? Let's see. McFadden choice model reduces the conditional logit with fixed effects if we only use our alternative specific variables. You know that. And compare those outputs. The McFadden choice model reduces to the multinomial logit model if we only include the case-specific variables. And, okay, we can get off that. What we can do, what we can't do using our McFadden choice model, which is our alternative specific case specific variables, alternative specific conditional logit, excuse me, is we can't use margins. What we can use is something that was before margins. So MFX stands for marginal effects, and if you type help MFX, it tells you exactly what's going on. MFX has been replaced by margins. Margins is better, it does more stuff, it has margins plots, it's easier to use, it's better in every way, shape, and form, unless, of course, margins doesn't work, which it doesn't. And it doesn't work for our alternative specific conditional logit model. So here's the old help file. It even tells you, we're going to keep this file in here for those losers that still want to insist on using it. We have to use it. We don't really have a choice. So State is catching up. It kind of tells you something about these methodologies. These methodologies are advanced to the point where State hasn't even, margins hasn't even caught up with some of these methodologies. And that's pretty cool. That means we're doing cutting edge analytics. Margins is only 3 versions old, maybe stated 13, 14, 12, 13, 14, something like that. Margins plots is even newer because it came after margins. So this is going to catch up. I've been saying this now for a couple of years. Margins is going to catch up to our McFadden choice model. It hasn't yet, but I guarantee it will. So MFX is nice. It's just not as powerful and doesn't have margins plots, and you can't export the results like you could. But what we can do is, this is what I mean by it's pretty nasty output. This is all the output from DStat MFX. All that. So, like I said, what I like to do is I'll use the graphics from margins plots from our multinomial logit model, knowing, of course, that it's not the right model. But look at what we get here. We get our marginal effects, which tells us, and again, these are nonlinear also, but we get our marginal effects from our McFadden choice model. And again, this is for Beach. For Beach there,